Hi students, last week we learned how to solve system of equations by graphing and using tables to find the point of intersection. This week we're going to use a new method called the substitution method to find the point of intersection and then check our work by graphing. And we want to make sure that we show all work when we're doing that. So let's begin. So our first equation is y equals 5 and our second equation is negative 12x minus 4y equals negative 8. Whenever we're trying to apply the substitution method, we want to do a couple things. First, we always want to make sure that we isolate for a variable. Okay, so we want to make sure that we isolate for a variable. After we isolate for a variable, we want to substitute the isolated variable into the other equation. And after we substitute the isolated variable into the other equation, solve for x and y. To find point of intersection. Or our solution. Okay, so we're going to follow these three steps. First, we want to isolate a variable. Then we substitute the isolated variable into the other equation. And then lastly, we solve for x and y to find the point of intersection. So we're going to start doing that first. We have y equals 5 and negative 12x minus 4y equals negative 8. Notice how from both of these equations, one of the equations already has an isolated variable. We know that y equals to 5, so y by itself. And this second equation, x or y are not by themselves. So we can skip the first step, isolate the variable, because y is already isolated. Our second step is substitute the isolated variable, so y, into the other equation. So we take this y and we plug it into the other equation. So let's try that out. So we have negative 12x minus 4y equals negative 8. And since y equals 5, instead of writing y, I'm going to write the number 5 by substituting. So negative 12x minus 4 times y, which is 5, equals to negative 8. Then we simplify. We get negative 12x, 4 times 5 is 20. So negative 12x minus 20 equals negative 8. Then we try to isolate for x. So solve for, we already know what y equals. Now we're going to solve for x to find the point of intersection. So add 20 on both sides. And we get negative 12x equals negative 8 plus 20 is positive 12. Then divide by negative 12 on both sides. And we get x equals to 12 divided by negative 12, which equals negative 1. So our point of intersection is going to equal to negative 1, comma 5, because those represent our x and y coordinates. We're going to test to see if this is true by graphing both of these equations. So I'm going to draw my x and y axis first. And my point of intersection is negative 1, comma 5, so maybe I want to skip by 2's. So our first equation, y equals 5. So we look at what y is 5. So 2, 4, 5 right here. And this equation means at any x value, y is always going to equal 5. So there's going to be at x equals 2, y is still 5. X equals 4, y is still 5. X at negative 6, it's still 5. So y equals 5 looks like this as an equation. Now we're going to take the second equation And in order to graph this second equation from standard form, we need to convert it into slope-intercept form. So negative 12x minus 4y equals negative 8. To get y by itself, we're going to add 12x on both sides. And we get negative 4y equals 12x minus 8. Slope is 12. Negative 8 is the y-intercept. But we don't have that yet until we divide both sides by negative 4, because we need it in y equals mx plus b form. So now we have y is equal to 12 divided by negative 4 is negative 3x. And negative 8 divided by negative 4 is going to give us positive 2. So we have our equation in y equals mx plus b form. So we start at our y-intercept, which is 2. We go down 3 and to the right 1. So 1, 2, 3, to the right 1, down 3, 1, 2, 3, to the right 1, down 3, 1, 2, 3, to the right 1, and so forth. And we go the other way, up 3, 1, 2, 3, to the left 1, 1, 2, 3, to the left 1, so forth. Then we connect our points. And you'll see that it's intersecting at the point negative 1 and positive 5. So it does match. This is actually the answer. When we plugged in the graph, we can see that they intersect exactly at that point. On to the second problem. So our first equation is x equals 9, and our second equation is negative 7x minus 9y equals 18. First, we want to isolate for the variable. The variable is already isolated, so x is by itself, and that equals 9. So we don't need to do nothing there. Then we substitute the isolated variable into the other equation. So we take this x equals 9 and substitute it into the other equation. So we'll plug in x as 9. So we have negative 7x minus 9y equals 18. And then instead of writing x, I'm going to write 9 instead. So negative 7 times 9 minus 9 times y equals 18. Negative 7 times 9 is negative 63 minus 9y equals 18. To solve for y, we're going to need to add 63 on both sides. And we get negative 9y equals to 81. Then we divide by negative 9 on both sides to get y by itself. And 81 divided by negative 9 is going to equal negative 9. So my point of intersection is going to be, my x coordinate is 9, and my y coordinate is negative 9. So that's what I believe is the point of intersection. I'm going to check my work using a graph. So because the point of intersection is 9, negative 9, I'm predicting that it's best to scale by 2s so that we can see if that point exists. And scaling by 1s is not going to get us there because it's 1, 2, 3, 4, 5. That doesn't give us 2, 9. That applies also to the y-axis. So for our first equation, x equals 9, we'll look at where x is 9. X is 8 over here, 10 over here, so 9 right here. Regardless of what y value it is, x is always 9. So if y equals 10, x will still be 9. If y equals negative 6, x is still 9 based on the equation. Y does not affect this equation. So we draw a vertical line. There we have it, x equals 9. Now, if we want to graph this standard form equation, we need to convert it to slope-intercept form. So negative 7x minus 9y equals 18. To get that in slope-intercept form, y equals mx plus b, we will need to add 7x on both sides. and we get negative 9y equals 7x plus 18. Then we divide by negative 9 on both sides to get y by itself. And now we have y equals to 7 divided by negative 9 is negative 7 over 9x. And positive 18 divided by negative 9 is negative 2. So we have our equation in slope-intercept form. Now we start with the y-intercept, which is at negative 2. And we go down 7 and to the right 9. So 1, 2, 3, 4, 5, 6, 7, and to the right 9. 2, 4, 6, 8, 9. And then we go up 7, 2, 3, 4, 5, 6, 7, and to the left 9. 2, 4, 6, 8, 9. And then we connect our points. And then we'll see that there's an intersection exactly at 9, negative 9. So once again, this works out. The graph matches the substitution method. So what if both equations have the variable already isolated? So step 1 was isolate the variable. Y. They both are by themselves. What we can do is set them equal to each other. So we have y equals 6x minus 1, and we have y equals negative 4x plus 9. So since they both equal to y, we can set y equal to y. In this case, the first y is represented by 6x minus 1, and the second y is represented by negative 4x plus 9. Now we solve for x, so we can add 4x on both sides. We get 10x minus 1 equals 9. Then we can add 1 on both sides. And we get 10x equals 10. Divide by 10 on both sides to isolate for x. And x in this case is equal to 1. Now that we know what x equals, we will want to solve for y. So step 1 was isolate for the variable. They're both already isolated. Step 2 is plug one equation into the other. So 6x minus 1 equals to negative 4x plus 9. And then step 3 is to make sure we solve for both x and y. We already solved for x, now we're going to solve for y. So I'll pick the first equation. You can pick either equation, y equals 6x minus 1 or y equals negative 4x plus 9. I'll pick the first one. Y equals 6x minus 1. And we're going to substitute x equals 1. So I'm going to plug in the 1 here. And we have y equals to 6 times 1 minus 1. 6 times 1 is 6 minus 1. 6 minus 1 is 5. So our point of intersection is going to equal to 1, 5. As a reminder, the word of the week for this week is substitution. Once again, the word of the week for this week is substitution. And you can put that word right underneath here for the word of the week, substitution. Okay, so now we have the equations. We're going to graph them. And the fortunate thing is that both of these are already in slope-intercept form. So we don't have to worry about doing any translations to get them into that form. And my point of intersection is 1, 5. I have a y-intercept at 9 and negative 1, so I might want to scale by 2's again. So the first one, 6x minus 1, negative 1 is my y-intercept. And my rise over run, or my change in y over change in x, is 6 up and 1 to the right. So 1, 2, 3, 4, 5, 6 up, 1 to the right. Then go the other way, 6 down. 1, 2, 3, 4, 5, 6 down, and 1 to the left. My line should look something like this. Once I have my first equation graph, I'm going to graph my second equation. Start at positive 9 as my y-intercept. Then I go down 4 and 1 to the right. So change in y is negative 4, change in x is 1, or my rise over run. So down 4, 1, 2, 3, 4, and 1 to the right. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right. Okay, so now I have all my points, connect them up, and there we go. So our point of intersection is right here where they cross, and that's at 1, 5. So it does match up with the original problem. Last but not least, we have one equation in standard form and the other equation in standard form. So as you recall, step 1 is to make sure that we isolate for a variable, and we're going to take this first equation and isolate for y. So negative 2x plus y equals negative 18. To isolate for y, we're going to add 2x on both sides. And our new equation now is y equals to 2x minus 18. So y is isolated. Once we isolate variable, step 2 is to take the isolated variable and plug it into the other equation. So we're going to do that. 3x plus 2y equals 6. And I'm going to write the same thing, 3x plus 2. And instead of writing y, I'm going to write in 2x minus 18, because that's what y equals. And then I'm going to put in equals 6. So 3x, still 3x, and we distribute the 2 times 2x and 2 times negative 18. So 2 times 2x is 4x, and 2 times negative 18 is negative 36. That equals 6. Then we add 3x and 4x, we get 7x minus 36 equals 6. Add 36 on both sides. And we get 7x is equal to 42, or in this case, divide by 7 on both sides. And we get x equals to 6. Once we solve for x, we're going to solve for y by plugging our solution x equals 6 into one of the two equations. You can choose either equation. I'll just use this one right here. So we have negative 2x plus y equals to negative 18. And instead of writing x, I'm going to write 6 in. So negative 2 times 6 plus y equals negative 18. Negative 2 times 6 is negative 12, plus y equals negative 18. Add 12 on both sides. And negative 18 plus 12 is positive 6. Negative 6, sorry. So my point of intersection for this last example is going to be 6, negative 6, because those represent my x and y coordinates. I'm going to verify if this is true by graphing both of the equations. So you might notice that both of these equations are not in slope-intercept form. So we need to convert that to slope-intercept form. So negative 2x plus y equals negative 18. I think I did that earlier, where it was y is equal to 2x minus 18. So this one actually I'm recognizing that I will need to have a higher scale because I don't have negative 18 on my graph. So I have to rescale my y-axis. So I'll wait for that in a bit. And I'll write the second equation, 3x plus 2y equals 6. Subtract 3x on both sides. You get 2y equals negative 3x plus 6. Then divide by 2. You get y equals to negative 3 divided by 2 is negative 3 over 2x. 6 divided by 2 is positive 3. So positive 3, negative 18. Probably scale by 3s. So 3, 6, 9, 12, 15. This out would be negative 3, negative 6, negative 9, negative 12, negative 15. Then I'll go down one more, and that will be negative 18. So scaling by 3's on my y-axis and 2's on my x-axis. So start at negative 18 as my y-intercept. Go up 2, so 17, 16, and then 1 over, because my slope is 2 over 1. Up 2, so 15, 14, 1 over. Up to 13, 12, 1 over, and so forth. And it should look something like this right here as my equation. Then for my second graph, I will start at positive 3 as my y-intercept. Go down 3 to 1, 0, and then 2 over. Down 3, negative 1, negative 2, negative 3, and 2 over. Down 3, so negative 3 to negative 6, and then 2 over, and so forth. And you'll see that they intersect at this coordinate. X is 6, and y is negative 6. So there we go.